Hi, good evening my dear 10th standard students. In the previous video, we have explained Ohm's law experimentally as well as graphically, and at the end of Ohm's law, we have defined the term electrical resistance of a conductor. Yes, how did we define electrical resistance of a conductor? It is the opposition offered to the flow of electrons by the conductor. How is this opposition created or caused? It is due to the collision of the free electrons with the ions which are vibrating inside the conductor. Okay. In the magic triangle, three expressions I taught you. V equal to I into R equal to V by I equal to V by R. You tell me, yes, you tell me what is the expression for electrical resistance? Yes, R equal to V by I. V means potential difference and its unit is volt. I means electric current and its SI unit is ampere. So what must be the unit for resistance? It must be volt per ampere. But another unit is there, I told you, it is ohm. Good. So ohm is the unit of electrical resistance. Now we want to define 1 ohm. 1 ohm. When is the resistance said to be 1 ohm? In this case, if V is equal to 1 volt and current I is equal to 1 ampere, in this case what will be the value of the electrical resistance equal to? Yes, good. R is equal to 1 by 1, that is equal to 1 ohm. So 1 ohm is the opposition offered by a conductor when the potential difference across the conductor is 1 volt and when 1 ampere current flows through the conductor. Have you all understood? Okay. Now one very important information I am going to tell you. There are some electrical devices which you are going to study in higher classes. Only some electrical equipments or some electrical devices will obey Ohm's law. So any device which obeys Ohm's law is called as a ohmic device or linear device. This is a very simple definition you can learn now also. So ohmic device or linear device means such devices obeys Ohm's law. So such devices will obey Ohm's law. For example, a copper wire, ordinary conductors and all we can say. So another type of devices are called as non-ohmic devices. Non-ohmic devices are also called as non-linear devices. Non-linear devices. What do you mean by non-ohmic device? Such devices will not obey Ohm's law. Okay. What are the examples we can give? I will tell you in the later stage only. We are going to study about the non-ohmic devices. These are all some semiconductor devices like the diode. See, this is one of the example which we are going to study in the higher classes only. But at least some introduction I will give you. These devices like diode, transistors, which are made up of semiconductors, It's a higher level topic, we will see later. Anyhow, there are some devices which obey Ohm's law. That is why they are called by the name ohmic devices. So ordinary copper wire or any metallic conductor. It is also called as linear device because if you draw a graph between voltage and current means the shape of the graph is a straight line passing through the origin. That is why they are also called as linear devices. Okay. Why non-ohmic devices are otherwise called as non-linear devices? Yes, your answer is correct. Your thinking is good. Okay. Because the graph drawn between the voltage and current is not a straight line but a curved line. Okay students, now we are getting into a very important topic and so many facts about the resistance of a conductor. So I am going to take you to the new topic. Before that, I will erase the board. Hi. Now, just now we defined electrical resistance of a conductor, and it is the ratio of the potential difference across the conductor to the current flowing through the conductor, and this will not be a constant always. The resistance of a conductor depends upon some factors. We are going to discuss on what factors does the resistance of a conductor depends. Now you look at the board. Here I have drawn two copper wires. One copper wire is of less length, short length, and the second wire is longer than the first wire. Now both are made up of copper wire only. Both are made up of copper wire. Now let us say inside this copper wire the free electrons, one electron I have taken, only one electron I have taken for example. So in the first wire, the electron has to travel a very short distance only. The electron has to travel a very short distance. So it is undergoing collisions with the positive ions. On the way, with whom does it undergo collision? With the positive ions. This only is called electrical resistance. Okay. In the second picture, the electron which has to reach the other end must undergo so many collisions. So large number of collisions are taking place for the second electron. So the electron in the first picture has to meet with a few collisions only, whereas the electron in the second picture has to undergo so many large number of collisions comparing to the first one. So naturally, you tell me the first wire or the second wire, which of these two wires will have more electrical resistance? Yes. Good. It is the second wire. It is the second wire. So I will take L1 is the length of the first wire and L2 is the length of the second wire. So L1 is less and L2 is greater. So L1 is less than L2. So the electrical resistance, the opposition met with by the electrons will be lesser in the first wire and greater in the second wire. It is just like large number of speed breakers on the way. So the automatically the speed will decrease for any vehicle. In the same way, when the length of the wire increases, means the electrical resistance of the wire also gets increased. Very simple idea. So from this, what I am going to write is the resistance of a conductor R is directly proportional to the length of the conductor L. Have you all understood? Yes, good. Now in the second set of pictures, you see that the first wire and the second wire both are made up of copper. Both are having equal length. Length of the wire will be the same. But what is differing, you tell me? Yes, the thickness is differing. When the thickness is differing means I can also say that the area of cross section, A is different. So this is A1, area of cross section 1, and this is A2. Which is greater? Yes, A2. The area of cross section of the second wire is greater than the area of cross section of the first wire. Now in this case, let us consider that the electrons are crossing every cross section and they are coming out. So these electrons are coming out. You can see that the electrons crossing the area of cross section every second. And in the second picture, can you see that more number of electrons can come out or not? Yes. If a door is opened narrowly, few persons only can come out. When the door is opened very widely, large number of persons can come out. Simple idea. That's good. Okay. Have you understood? Good. So, in which of these two wires, more number of electrons can cross the area in a same time or in a short time? That is the second wire. So, for a given instant of time, for a given time taken, in the first wire only few electrons can cross. While for the same time in the second wire of greater thickness, more number of electrons can cross the area. That means here in the second wire conduction is more. When conduction is more, resistance is less. Similarly, in the first wire, very few electrons only are coming out, means the conduction is less. That means the current is less. So there is a large opposition. That means what? How does the resistance depend upon the area of cross section? Is it directly or inversely? Very good. It depends inversely. So I can summarize that the resistance of a conductor is inversely proportional to the area of cross section. Is it not? Have you all understood or not? Good. So from the first set of two wires, what I have inferred, the resistance of a conductor is directly proportional to its length. And from the second set of example, what we have found is the resistance of a conductor is inversely proportional to the area of cross section of the wire. Now I am going to group these two terms and write R is proportional to L divided by A. Okay, this is not an equation, it is an expression. There is a proportionality constant. So I am going to convert this into an equation. Therefore, the resistance of a conductor is equal to some constant of proportionality. This constant of proportionality is denoted by the Greek symbol rho, R-H-O, rho, and into L by A. So R is equal to L by A is the final expression for the electrical resistance, where this constant of proportionality rho is defined. Okay, this is a constant of proportionality and it is named as resistivity. This is named as resistivity. Resistivity or specific resistance. Specific resistance. Okay, specific resistance of whom? It is a specific resistance of the material with which the wire is made up of. It is the specific resistance or resistivity of the material with which the wire is made up of. For example, the wire is made up of copper. This wire is made up of copper. So what is the rho? Rho is the resistivity of copper. If the wire is made up of aluminum, means what must be rho then equal to? It is a specific resistance or resistivity of aluminum. Instead of copper, any other material can also be used. So what did I say? What is the rho means? Rho means, what did I say? It is the specific resistance of the material of the conductor. What is the other name I told? It is also called a specific resistance. Good. Now we want to define specific resistance. You see here, I am going to define now specific resistance. This specific resistance of any material depends on which factor, means nature of the material only. Nature of the material. So you get an expression for rho from this equation. I want an expression for rho. So rearranging the terms, shall I write rho is equal to R into A divided by L. Okay. So rho is equal to R into A divided by length L. Is it not? Okay. Suppose if the area of cross section is equal to 1 meter square and the length of the wire is equal to 1 meter, then what will be rho equal to? Rho will be equal to R itself. R. Is it not? Rho is equal to R. So from this expression only we can get the definition for specific resistance. We want to define the specific resistance of a material by assuming the length of the wire as 1 meter. 1 meter is called unit length. And by assuming the area of cross section as how much? Yes, 1 meter square. It is also called as what? Unit area. So now we have got a beautiful definition for specific resistance. The resistivity or specific resistance of a material rho is defined as the resistance. It is defined as what? The resistance offered to the flow of current. By whom? By a conductor having unit length and unit area of cross section. Yes, shall we repeat once again? That's good. The specific resistance of a material is defined as the resistance offered to the flow of current by a conductor of length 1 meter and area of cross section 1 meter square. Okay, fine. I am going to now derive the unit for specific resistance. Can anyone guess what must be the unit of specific resistance? Is it ohm? No, it is not ohm. Resistance has a unit of ohm, while specific resistance has some other unit. Let us take the expression for the specific resistance once again. Rho is equal to R into A divided by L. Is it not? Okay. Now R is the resistance of the conductor. What must be the unit of resistance? It is ohm. Good. That is ohm. Okay. I will write this is equal to ohm. What is the SI unit of area? Yes, it is meter square. That's right. Okay, meter square divided by length. Yes, it is meter. Good. You are all good. So this meter and this square term is getting cancelled. So what is remaining? It is ohm into meter. So this unit is ohm meter. Ohm meter is the SI unit of what? The specific resistance or resistivity. Good. Now, before summarizing these points, I will tell you another very important definition. If you take the reciprocal of specific resistance, this is 1 by resistivity. 1 by resistivity is called as conductivity. It is called as conductivity. The reciprocal of resistivity is called as what? Conductivity. Resistance means opposing, conduction means what? Sending the current. So you imagine what should be the unit for conductivity? The conductivity is having a symbol sigma. Tell me, sigma. Good. So this is like a horizontal 6. Okay. Anyhow, sigma means what? Electrical conductivity. How do you define? It is a reciprocal of resistivity. So naturally, the unit of conductivity must be equal to what? 1 divided by ohm meter. So this is equal to ohm power minus 1 into meter power minus 1. This ohm power minus 1 also is called as mho. It is just the reverse of ohm. Okay, this is mho. So mho, and this is per meter. So this is mho per meter. It is what? Mho per meter. Similarly, if you take the electrical resistance, for example, what should be the reciprocal of the resistance also? Let us see now. 1 by R. 1 by R is denoted by the symbol G. G means it is conductance. It is called as what? Conductance. So the reciprocal of resistance is called conductance, and the reciprocal of resistivity is called conductivity. Okay, so what must be the unit of G then? Conductance. This is equal to what? 1 divided by ohm. That is ohm. That is equal to mho. So this is 1 divided by ohm is also called as what? Mho. Ohm to the power of minus 1. Okay students, now today what we have studied, I will summarize very quickly. We have defined electrical resistance of a conductor. It is the ratio of the potential difference across the conductor to the current flowing through the conductor. What is the SI unit of electrical resistance? Yes, that is ohm. And what is the expression for resistance? R equal to V by I. If V is equal to 1 volt and I is equal to 1 ampere, what will be the value of R equal to 1 ohm? Good. After that, we have studied on which factors does the electrical resistance of a conductor depends. So from this expression, R equal to rho into L by A, R is directly proportional to the length of the conductor. R is inversely proportional to what? The area of cross section or thickness of the conductor. And R also depends upon specific resistance of the material of the conductor. From this equation, we find that the resistance depends on only 3 factors. But one more factor is there, that in the beginning class itself I introduced that the resistance of a conductor will change with temperature. Is it not? That is why I told you that while defining Ohm's law, At constant temperature only it is true, I told you. This is because when you heat any conductor, what will happen to the ionic vibrations? It will increase. So what happens to the number of collisions made with the electrons? That will also increase. As a consequence, the resistance of the conductor will also increase. So my dear students, you must remember that there are 4 factors on which the resistance of a conductor depends. In this expression only 3 factors are visible to us. What is the 4th factor I told you? Yes, good. That is the temperature. Okay, now finally you tell me what are the 4 factors on which the resistance of a conductor depends. Yes, length of the conductor, area of cross section of the conductor, the nature of the material of the conductor, and the 4th factor is the temperature. I hope you all must have enjoyed this lecture. Okay, fine. You will go home and read the contents. In the next lecture, we are going to solve numerical problems first. Okay? Bye. Bye.